What happens when you put a medieval piece of linen under a microscope and you suddenly realize the physics required to create it? Well, they demand 14,000 modern high-powered lasers.
Yeah, it's a completely absurd premise when you first hear it.
Right. I mean, today we are looking at an object that literally breaks the foundational laws of thermodynamics. So welcome to the deep dive.
Thanks. We are really stepping into a profound scientific headache today. I mean, when we observe the physical world, we expect classical mechanics, quantum physics, and thermodynamics to act as this reliable operating system of reality.
Like the rules of the game.
Exactly. They provide the predictable constraints that tell us what is actually possible. But the source material we are examining today introduces a physical system that completely crashes that operating system.
And the mission for this deep dive is a wild one. We're unpacking a highly technical, incredibly rigorous academic dissertation focused entirely on the Shroud of Turin.
Which carries a lot of baggage for people.
Oh, absolutely. So if you think you know where this conversation is going, you can just throw that out the window right now.
Yeah.
This is not a discussion about history.
Hmm.
It is not about theology or religion. We are leaving all of that completely at the door. We are looking at this strictly through the lens of impossibility theorems and hard physical constraints.
Yeah, and what this dissertation does, which is honestly a brilliant approach for any scientific anomaly, is it treats the shroud purely as a physical system.
So no historical assumptions.
Right, none at all. Instead of trying to prove what did cause the image, it uses the laws of physics to establish negative constraints. It meticulously calculates what physically could not have caused it.
It's like a massive, unforgiving process of elimination using the foundational laws of the universe.
Exactly.
Okay, let's unpack this. Because to understand why this piece of cloth is breaking the brains of physicists, we really have to start with the fundamental physical characteristics, the boundary conditions.
You have to know what it is before you can ask how it got there.
Right. Before we can even guess how it was made, we have to look at what it is.
Yeah.
And what is honestly mind-bending.
So let's set the physical stage here. We are talking about a piece of linen cloth woven from flax. It is exceptionally thin, just 0.34 millimeters thick.
Which is what, like a few sheets of paper?
Yeah, roughly the thickness of 3 sheets of standard printer paper stacked together. But the image on this cloth isn't like a painting or a die.
No, it's something entirely different.
Right. The defining characteristic of this image is something called superficiality.
And when we say superficial, we are talking about microscopic physical depth.
Truly microscopic. The image only sits on the absolute topmost fibrils of the linen threads. It penetrates to a depth of just 0.2 micrometers.
Oh, wow.
Yeah, to put that in perspective for you, a single human hair is about 100 micrometers thick.
So this image coloration is 1/500th the thickness of a human hair.
Precisely. And it is not made of pigment. It's not paint. It's not a scorch mark from a fire.
So what is it then?
The coloration is purely the result of the oxidation and dehydration of the cellulose itself. The cloth essentially aged rapidly and specifically, but only on that microscopic top layer.
Which is weird enough on its own. But then the source material introduces a concept that completely breaks normal physics, which is double superficiality.
Yes, this is where it gets crazy.
Because the image exists on the front surface of the cloth, and it exists on the back surface of the cloth. But the interior of the fabric, like the middle of that tiny 0.34 millimeter thickness, is completely blank.
Right. This specific characteristic starts to lock us into a very tight physical corner.
I was trying to visualize this, and the only analogy I could come up with is toasting a piece of bread.
Okay, I like that.
Like imagine you put a slice of white bread in the toaster, but somehow only the absolute microscopic outer crust on the top and the microscopic outer crust on the bottom gets browned.
But the inside is totally unaffected.
Exactly. The inside remains perfectly raw, untouched, soft white bread. And if I'm thinking about how a medieval artist would paint something, that bread analogy ruins the forgery idea.
Oh, completely.
Because if someone painted this cloth, the liquid would soak in, right? Capillary action will pull the paint right into the middle of the threads, making the inside of the bread completely soggy.
Yeah, fluid dynamics dictate exactly that. Capillary wicking is a basic transport phenomenon, and thermal conduction works the exact same way.
So a hot statue wouldn't work either.
No, if you applied a hot metal statue to the cloth to scorch it, well, Fourier's law of thermal conduction dictates that the heat would spread, creating a gradient.
Right.
The heat doesn't just magically stop at the crust, It conducts through the material, warming the inside.
So the fact that the inside is pristine white linen proves that whatever made this didn't soak and it didn't conduct heat.
Exactly. It proves the image formation mechanism is entirely non-diffusive and non-penetrating.
Meaning it didn't travel through the material.
Right. Whatever energy or chemical reaction caused this, it interacted only with the extreme outer boundaries without traveling through the middle at all.
Which brings us to the first major hurdle for anyone trying to explain this. The technological tripping point.
A huge hurdle.
Because since this image exists in the physical world, the first, most logical assumption any scientist makes is that a human being made it.
Of course. That's where you have to start.
Right. So if we assume a medieval forger in the 1300s or 1400s pulled this off, how did they do it?
Well, according to the impossibility theorems in our source, they just couldn't have.
Period.
The dissertation looks at the sheer energy required to replicate this specific superficial oxidation. And scientists at a major research facility in Italy called NA, they actually managed to replicate this exact coloration and the 0.2 micron depth on linen.
Oh, wow. So they did actually recreate it?
They did, but, and this is a massive but, the technology required is the catch. To pull it off, they had to use excimer lasers producing vacuum ultraviolet radiation. Yes. Specifically, wavelengths under 200 nanometers. And they couldn't just use one laser either.
Let me guess, they needed a few.
To produce a full-body image of that size without burning the cloth, the mathematical models show you would need 14,000 of these excimer lasers operating simultaneously.
Okay, hold on. 14,000 modern lasers. Why lasers? I mean, why couldn't they just use a really bright light or a fire?
Because vacuum UV light is incredibly unique. It has such a high frequency and short wavelength that the moment it hits the very first electron cloud of a surface atom, all of its energy is instantly absorbed.
It doesn't travel any further.
Right. It breaks the chemical bond of the cellulose right there on impact. It literally cannot travel any deeper into the fabric.
Okay, but a fire can't do that.
No. Thermodynamic sources like fire, hot metal, or sunlight, they produce visible or infrared light. Infrared heat penetrates and cooks the whole thread.
So the inside of the bread gets toasted.
Exactly. And visible light doesn't carry enough energy to instantly oxidize cellulose without first heating the whole cloth.
Yeah.
Generating vacuum UV requires 20th century quantum mechanics, high voltage discharges, noble gases.
So it's technologically anachronistic by over half a millennium.
By a long shot, yeah.
But let me play devil's advocate here.
Go for it.
Couldn't an incredibly skilled medieval alchemist, or like someone who really knew their stuff back then, just use a really, really faint acid wash?
Okay, I see where you're going.
Or maybe a primitive silver nitrate photography technique to get that superficial depth?
Yeah.
I mean, human beings were incredibly clever with chemistry long before we had lasers.
It's a fair question, but the dissertation addresses those chemical specificity constraints directly, and it shoots that idea down completely.
Oh, really? Oh,
Because medieval alchemy, no matter how clever, was chemically messy. If you use an acid wash like vitriol or a base like lye, it leaves microscopic chemical traces. Right. If you use silver nitrate like an early photograph, you need reducing agents. Those processes inevitably leave behind iron, sulfates, chlorides, or heavy metals.
And I'm assuming modern analysis looked for all of that.
Thoroughly. The STIRP analysis, which was a massive, multidisciplinary scientific examination of the cloth back in the late 70s, they specifically hunted for these exact chemical signatures.
Using what, like microscopes?
X-ray fluorescence, tape lifting techniques, all sorts of things, and they found absolutely zero trace of iron in the image areas.
Wow, zero.
Zero. They found no sulfates, no chlorides, no protein binders from paint like collagen or egg tempera. The image is pure, unadulterated, oxidized cellulose.
So no messy medieval chemistry.
None. To get a chemical reaction that pure without any byproducts, you need modern controlled atmospheres and chemical purification tech that simply didn't exist in the Middle Ages.
Plus, even if they somehow had perfectly pure chemicals, any contact method like rubbing or pressing a chemical onto the cloth would ruin the superficiality.
Absolutely.
Because the sheer mechanical pressure of pushing a tool against the weave forces the modification deeper than that zero point 0.2 micrometer limit.
Yeah, the physical friction of a brush or a stamp instantly violates the depth constraint.
Okay, so if a medieval genius didn't fake it using anachronistic technology or perfectly pure alchemy, the next logical step on the scientific ladder is a natural biological process.
Right. Nature is pretty incredible, so we have to check that box.
Exactly. Could a decaying human body, or maybe someone experiencing a massive fever wrapped in linen, just naturally create this image over time?
This is where the physics gets incredibly strict, creating a massive biological roadblock.
Okay, hit me with it.
Well, we've established that the only way to get this exact type of superficial oxidation without chemicals is intense short-wavelength energy like vacuum UV.
Right.
So the question is, can a biological system, a human body, emit vacuum UV radiation naturally?
I mean, humans emit body heat,
Yeah.
which is infrared radiation, like we glow on thermal cameras.
We do. And to figure out if we can emit UV, physicists use Planck's law of blackbody radiation. This is a fundamental, unbreakable law of thermodynamics.
Sounds serious.
It is. A human body sits at about 310 Kelvin, which is 37 degrees Celsius. If you plug 310 Kelvin into Planck's equation to find the probability of that body emitting a single 200 nanometer vacuum UV photon.
Just one single photon.
Just one. The math gives you a probability of e to the negative 232.
E to the negative 232.
Yeah.
Okay, for those of us who don't dream in calculus, how small is that number in practical terms?
It is a decimal point followed by over 100 zeros.
Oh my God.
To put that in perspective, there aren't even enough atoms in the observable universe to make that probability happen even once over the entire lifespan of the cosmos.
That is, wow.
Yeah. It is a number so infinitesimally small that, for all practical purposes in the physical universe, it is absolute zero.
It's like expecting a warm cup of coffee sitting on your desk to suddenly start emitting lethal X-rays just because it's hot.
That's a great way to put it.
It's not just unlikely, it violates the thermodynamic laws of the universe. Biological bonds just don't have that kind of energy.
Exactly. Biology operates at very low energy levels. The bonds in organic molecules are weak. There is no biological mechanism, no evolutionary pathway, and no physical loophole that allows a human body to suddenly become a high-energy vacuum UV lamp.
What about particles, though?
What do you mean?
Could a body undergoing some weird, hyper-accelerated decomposition process shoot out protons or electrons that scorch the cloth?
Well, the mathematical models cover charged particles as well. First, if a body started shooting off charged particles, it would build up a lethal electrostatic potential, violating the conservation of charge.
Which is another unbreakable rule.
Right. Second, particles, like protons, have a very specific stopping distance in the air. A proton with the specific energy needed to modify cellulose, which is about 6.4 electron volts, would be stopped by the very first atomic layer of oxygen or nitrogen it hit.
So it wouldn't even reach the cloth?
No. Its range is microscopic. It could never cross the tiny gaps of air between a body and a draped cloth to create an image.
And we keep coming back to that diffusion problem we talked about earlier with the toast. If a body is rotting, it's off-gassing. It's releasing ammonia or other vapors.
Yes. The double superficiality constraint strikes again here. Fixed laws of diffusion tell us that natural chemical diffusion-like gases seeping out of a body always peaks in the center of a material.
Because it just follows the path of least resistance.
Exactly. If ammonia gas from a body caused the image, it would be darkest in the middle of the threads, not perfectly isolated on the extreme outer boundary.
Right.
To get the shroud's double superficiality naturally, a chemical gas would have to magically know exactly where the front and back surfaces of the cloth are, skip the middle entirely, and only react on the outside.
Which classical physics doesn't allow.
Yeah.
You can't have a non-local effect where a chemical just teleports past the center of the fabric.
No, not at all.
Natural processes are local, they follow gradients, they seep, they spread, they
The
diffuse.
physical evidence leaves no room for local natural diffusion.
Okay, so human forgery is mathematically and chemically ruled out. Natural biological decay is thermodynamically ruled out.
Right.
But the source material introduces one more piece of evidence that is honestly the most baffling part of all of this.
The spatial information.
Yes, the 3D depth map dilemma. This image isn't just a flat picture, it's an actual topographical map.
This is a fascinating constraint. When scientists put photographs of the Shroud into a VTA image analyzer,
What is that exactly?
it's an instrument originally used by NASA to map the topography of planets like Mars. So when they put the Shroud images into this analyzer, they discovered something shocking. The VP8 translates the darkness of an image into vertical relief.
Oh, wow.
And on the Shroud, the intensity of the image, how dark it is at any given point, correlates perfectly with the vertical distance that point on the cloth would have been from a physical body underneath it.
So if the cloth was resting right on the tip of the nose, the image is very dark.
Right.
But if it was draped over the cheek, leaving a gap of, say, 1 centimeter of air, the image is lighter. And if it was draped over the collarbone with a 2 centimeter gap, it's even lighter.
Yes. It encodes a mathematically precise depth map of a three-dimensional object.
But wait, let me push back on this because I feel like we take 3D photos all the time. Don't regular cameras do that?
No, they don't.
Even a medieval artist with a camera obscura captures 3D space, right?
This is a crucial distinction, and the text is very clear on why that doesn't work. Photography does not capture distance.
It doesn't.
No, photography captures light intensity and angle. It captures shadows based on where the sun or the flash is pointing. If you put a normal, regular photograph of a human face into a VPA analyzer, you don't get a 3D shape.
What do you get?
You get a distorted, chaotic mess.
Because the analyzer just pushes the dark shadows up.
Exactly. So if there's a dark shadow cast underneath the nose from an overhead light, the VPA reads that dark shadow as close and the bright tip of the nose as far away.
Oh, that makes sense.
The face turns into a crater-filled, unrecognizable landscape.
Ah, I see. So the camera only knows how bright the light is, not how far away the object actually is.
But the Shroud image has absolutely no directional lighting. There are no cast shadows. It captures purely distance.
Which is completely different.
To do this, you need three very specific things. Range-finding capabilities, distance to intensity transduction, meaning a mechanism that perfectly converts a physical distance measurement into a shade of color, and no dependence on lighting angles.
It's like pressing your face into one of those metal pin art toys.
Oh, yeah.
You know, the pins that push back the furthest are the ones closest to your face. The toy is literally mapping the physical distance of your features.
That is a perfect analogy.
So the Shroud isn't acting like a camera at all.
Yeah.
It's acting more like modern LiDAR or radar,
Yeah.
scanning the topography of the ground from an airplane.
The pin art toy is a brilliant way to visualize it. And again, natural processes are local. They cannot measure an air gap.
Right.
Manual painting would require a medieval artist to measure the distance from a body to the clock at every single micropoint, and then transduce that distance into a specific intensity of color.
Which is impossible.
With 0.5 millimeter precision across 2 square meters of fabric without leaving a single brushstroke.
Which brings us to an epistemological dead end. We are staring at a massive gaping hole in our understanding of physics. The source document calls this the Trilemma.
Yes. The Trilemma states that the image was formed by either medieval technology, natural biological processes, or an unknown mechanism. But the dissertation proves that the first two are physically impossible. The mathematical models quantify this as an explanatory deficit.
How big of a deficit?
The medieval forgery hypothesis is off by a factor of over 10 to the 10th power. Natural processes are off by 10 to the 8th power.
So what does this all mean for you, the listener? We have an object that sits right in front of us. You can touch it, you can measure it, but the physics required to make it simply do not exist in our current scientific tool belt. The text calls this the physical gap.
And what's fascinating here is how this compares to other frontiers in modern physics.
Like what?
Think about dark matter or dark energy in cosmology. We can observe the gravitational effects of dark matter on galaxies. We know it's there, pulling on stars, but we have absolutely no idea what it actually is.
It occupies a blind spot in our physics.
Right. It's a placeholder name for our own ignorance.
Exactly.
The Shroud represents the same kind of frontier. It is a macroscopic physical object that implies physics not yet discovered.
So the paper actually suggests there's new physics to be found.
It does. It theorizes about possibilities like a corpuscle wave or some incredibly complex, unmodeled abiotic chemistry that might take decades to form under highly specific, perhaps subterranean conditions.
Oh.
But right now, it occupies a configuration space entirely outside our accessible regions of science.
Which naturally leads to the ultimate question. What do we do now? If you are a scientist and you hit a wall this hard, you don't just throw your hands up and give up.
Never.
The dissertation wraps up by noting what the scientific method can do to start chipping away at this physical gap.
And the future research proposed here is incredibly high-tech. It treats the cloth like a cosmic anomaly.
What are they suggesting?
To close this gap, the author calls for CMD-style computational analysis. That is the exact same statistical mathematics we use to study the cosmic microwave background radiation from the Big Bang.
That's intense.
They want to use hyperspectral imaging and femtosecond lasers that pulse in quadrillionths of a second, fast enough to actually film chemical bonds breaking, to map the exact chemical kinetics of the cloth.
They want to find the microscopic signature of whatever energy burst or slow-acting field created this.
Physically, it is an anomaly right here on Earth, and it demands the highest level of our diagnostic tools to understand its mechanics.
We started this deep dive by asking, what happens when a piece of linen demands 14,000 lasers to replicate? And we've seen how the boundaries of thermodynamics, chemistry, and spatial mapping are pushed to their absolute breaking points by this single object.
It's a lot to take in.
It really is. But this leaves us with a profound philosophical twist. Science works by predicting, verifying, and falsifying. You make a hypothesis, you test it, you prove it wrong, or you prove it right.
And when an object permanently resists falsification, it forces us to reconsider the completeness of our scientific models.
It demands we look for entirely unmapped layers of interaction in the physical world. If macroscopic objects like this can undergo unmapped quantum or high-energy physical events that leave perfectly encoded 3D depth maps on linen, well, it makes you wonder, how many other miracles or unexplained magic throughout human history were actually just this exact same undiscovered physics temporarily showing its hand? Something for you to ponder long after this deep dive ends.